In this video, we are going to talk about multiplying and dividing fractions and mixed numbers. Imagine you have a circle and I want you to shade 1/2, not of the circle, but 1/2 of 3/4 of the circle. So your first job is to get this 3/4 part right. So what you want to do is cut the circle into 4 equal pieces. And then pick 3 out of those 4 pieces. So let's go for this. This is not the final shaded area. And this. And this. And then to get 1/2 of this shaded region, maybe we could split each one of these right through the middle. So this is what I mean. And pick one of these pieces. So you have one from here, right through the middle. And one from here. And this is what we mean by 1/2 of 3/4 of the whole. Now the question is, what fraction of the whole circle is shaded in red? And to figure that out, we need to cut this piece, the one that we didn't pick initially, into 2 equal parts. And then count the total number of pieces equally sized. At least that's what I meant them to look like. So count them all. So we have, let's start from here, 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 equal size pieces, and out of those 8 pieces, 3 have been shaded. The red portion is the one we are looking for, 1/2 of 3/4. Therefore, we could just go ahead and conclude that 1/2 of 3/4 is the same as 3/8, because 3 pieces out of 8 equally sized pieces have been shaded. Now let me tell you, in math, most often when you come across this word of, it means multiplication. Of means multiplication. So 1/2 multiplied with, or 1/2 times 3/4 is 3/8. Do you see a relationship between the numbers over here on this side and the answer to the multiplication? Yes, there is. If you look at the numerators, 1 times 3 gives you 3, the numerator of the answer. Similarly, if you look at the denominators, 2 and 4, 2 times 4 gives you 8, the denominator of the answer. So in other words, we could say that 1/2 times 3/4 is the same as 1 times 3 over 2 times 4. This is what we are guessing at this point. Let's take another example. Imagine we have a rectangle now, and we want to shade, let's say 1/3 of 4/5 of the rectangle. Once again, our first job is to nail this down. Get the 4/5 right, because then we are going to pick 1/3 of that. Let's try our best to cut this rectangle down into 5 equal pieces. Usually when I have to cut something down into 5 equal pieces, this is how I go about. I do 2 and 2 and 1. And then for each one of the 2's, I split them right through the middle. I know they're not equal size, but you can assume they're all equal size. 1, 2, 3, 4, 5. There you go. So 4/5 is going to be all of this. right? And then we need 1/3 of this shaded region. So we can cut down each one of these small pieces into 3 equal parts. Let's just assume they're all equal. So here you go. If you shade this portion, that's going to give you, this small rectangle out here is going to give you 1/3 of 4/5 of the whole. And once again, the question is, what fraction of the whole rectangle is shaded? And to be able to answer that, we need to do the same with the unshaded rectangle. That is, cut it into 3 equal parts. Now we could see that, okay, we have 1, 2, 3 rows of 1, 2, 3, 4, 5 columns. Therefore, we have 3 times 5, which is 15 small rectangles in all. These are the small rectangles. And as we can see out of them, 1, 2, 3, 4 have been shaded. So we could say, okay, 1/3 of 4/5 is equal to 4/15. And if you replace off with multiplication, like I said, so we have 1/3 times 4/5 is equal to 4/15. And that rule works on this one as well. So when you multiply the numerators, 1 times 4, it gives you the numerator of the product. When you multiply the denominators together, 3 times 5, you get 15, which is the denominator of the product. So we can safely conclude that when we multiply 2 or more fractions, the answer is a fraction whose numerator is the product of the numerators of the fractions you're multiplying, and the denominator of the product is the product of the denominators of the fractions you are multiplying. Well, it's not always that you will get a chance to draw circles or rectangles or other models in order to multiply fractions. Going forward, you will need to work with the numbers given. Let's do a few examples. Let's say you want to multiply 3/4 with 2/3. You know the steps. The answer is going to be another fraction. On the top, you have the product of the numerators, 3 times 2. On the bottom, you have the product of the denominators, 4 times 3. 3 times 2 is 6 on the top. 4 times 3 is 12 on the bottom. But hey, hang on. Look at this fraction 6/12. That can be simplified. You can divide 6 and 12 with 2, with 3, or even with 6. We are going to go with the GCF. That is 6. We are going to divide 6 with 6 and 12 with 6. Keep in mind that this slash represents a fraction bar, and a fraction bar, by now you know, that is equivalent to dividing. So 6 divided with 6 is 1 on the top, 12 divided with 6 is 2 on the bottom. So 3/4 times 2/3 is equal to 1/2. If you followed these steps and you got 1/2 in the end, you got it right. But I would like to show you how to do this problem in a better way. Now, if you look at this step, 3 times 2 over 4 times 3, you know that multiplication is commutative, which means the order in which you multiply the numbers doesn't matter. Now, what I'm going to do is, I'm going to rewrite this as 2 times 3. 3 times 2 is the same as 2 times 3 over 4 times 3, and then apply some reverse engineering, if you want to call it that way. In other words, if you look at this portion, you would have thought that this comes from the fraction 2/4, and this portion comes from the fraction 3/3, right? So if you multiply 2/4 with 3/3, which is not the same as the actual problem, you would still end up having 2 times 3 or 3 times 2 on the top and 4 times 3 on the bottom. Now look, this 2/4 is equivalent to 1/2 because you can divide 2 with 2 and 4 with 2. So this is 1/2, and then this 3/3, a number over itself, is always equal to 1, other than when the number is 0. So 0 over 0 is not defined. Anything else over itself is always 1. And so in the end, we have 1/2 times 1, which is 1/2. It's the same answer as this one. But the difference in the two methods was that in the first method, we first multiplied and then we simplified the fraction. Remember, we had got 6 over 12 and then we simplified that to 1/2. In the second method, we first simplified the numbers and then in the end we did the multiplication. Now, if you take a look at the original fractions, we had to multiply 3/4 times 2/3. You'll probably realize that we reduced or simplified this 2 with this 4 and this 3 with this 3. So in order to simplify the numerators and the denominators, they don't have to be exactly one below the other when you're multiplying fractions. You can pick any of the factors from the numerator and reduce it or simplify it with any factor from the denominator. And that works because multiplication is commutative, which means you can move the factors around. And it's equivalent to this 2 being over this 4 in place of this 3. And you should always multiply fractions using this method. It's a good practice. First simplify, then multiply, rather than first multiplying and then simplifying. In easy problems, you probably won't realize the difference. But let me give you another example to show you why this method is preferred over the other one. Let's say you need to multiply 6 over 11 with 55 over 18. Now, if you choose to first multiply and then simplify, this is what you get. You get 6 times 55 on the top and 11 times 18 on the bottom. It takes you a little while to figure out that 6 times 55 is going to give you 330. 11 times 18 is going to give you 198. This is an improper fraction. That's not a surprise because you're multiplying with an improper fraction. So you can get an improper or a proper fraction in the end. It depends on the fractions. Look, when you're multiplying two improper fractions, that means two numbers, both of which are larger than 1, you would end up getting a number that's larger than 1, which means you will end up getting an improper fraction as the product. On the other hand, if you're multiplying both proper fractions, or two or more proper fractions, which means you're multiplying several numbers, two or more numbers less than 1, so the final answer is also expected to be less than 1, which is a proper fraction. But on the other hand, if you have a mixture like over here, you have a proper fraction times an improper fraction, meaning something less than 1 times something more than 1. So it really depends on the numbers whether you're going to get a proper or an improper fraction in the end. As it turns out in this problem, we end up with an improper fraction, but 330 over 198. Number one, it took you a while to figure out the multiplication. Number two, you need to simplify this. Think of a number that can divide 330 and 198. That's not too easy. So you probably start with 2. Divide this with 2, this with 2. 330 divided with 2 is 165 on the top. 198 divided with 2 is 99 on the bottom. Now, it's time for us to divide this and this with a common factor. 165, the moment you look at it, ends in a 5. You think of 5 dividing this with 5, but unfortunately 5 can divide 99, so that doesn't work. 3 works, yes. You can divide both these numbers with 3. 165 divided with 3 is 55 on the bottom, and 99 divided with 3 is 33. Now you know that you can divide both of these with 11. So you have a 5 on the top and a 3 on the bottom, which is 5/3. This is still an improper fraction. Obviously, when you get an improper fraction and you start simplifying it, in the end, no matter what, you get an improper fraction. An improper fraction cannot be simplified to a proper fraction. Okay, so if you want to simplify this, you can simplify it. If you want to change this to a mixed number, you know what to do. Divide 5 with 3, you get 1. 1 is the whole, and then the remainder is 2. and the denominator is 3. The answer to the multiplication of 6/11 with 55/18 is 1 2/3 or 5/3 as a fraction. It involves several steps, some decent multiplication and division. But look what happens if you prefer to go the other way. If you start with 6/11, 55/18 and keep in mind that you can simplify any number or any factor from the numerator, I call it the numerator scheme, with any factor from the denominator scheme, so you can easily figure out that 6 can divide 18, so you can divide this with 6 and this with 6. And similarly, 55 can be divided with 11, this with 11, this with 11. 6 over 6 or 6 divided with 6 is 1 on the top. 11 over 11 is 1 times 55 over 11 is 5. 18 over 6 is 3. Straight away, we ended up having 5/3. 1 times 5 is 5. 1 times 3 is 3. And that obviously changes to the mixed number 1 whole and 2/3. Look at the number of steps it took us to get to the final answer. So it's always a good habit to first reduce or simplify, and then if you cannot simplify any of the numerators with any of the denominators, it's only then when you go for the final multiplication. Do not multiply before you have tried the simplification process. And here comes another example to prove my point. Let's say we want to multiply 14 over 15 with 20 over 9. So we have a proper fraction times an improper fraction. And hang on, I'm not done. This multiplied with 27 over 35. How about that? Now imagine multiplying 14 with 20 with 27 and getting a big number on the top. Multiplying 15 with 9 with 35, getting a big number on the bottom and trying to simplify that fraction. That's going to take you time, right? I have a better idea. I know I can simplify any of these numbers on the top with any of the numbers on the bottom. I see a 14 here and a 35 here. So I'm just going to go ahead and divide both of them with 7. Smart idea, right? I'm not done. Well, I spotted a 9 here and a 27 here. I know that the GCF of 9 and 27 is 9 itself. So I'm going to divide this with 9 and this with 9. And I'm not done, because now I see a 20 and a 15. And I know I can divide both these numbers with 5. How about that? Time for us to simplify. 14 over 7 or 14 divided with 7 is 2 on the top. 15 over 5 is 3. It doesn't matter, we change the fraction. If you look at this fraction, we have not followed the process of simplification. We have divided the numerator and the denominator with different numbers. But you know, with fraction multiplication, it doesn't matter as long as you can do it with one number, any one from the top and any one from the bottom. So we have a 2 over 3 here to be multiplied with 20 divided with 5 is 4. 9 divided with 9 is 1. Numbers getting much smaller than what we had. Times 27 over 9 is 3. 35 over 7 is 5. And look at this. I'm not done. I can still divide 3 with 3 and 3 with 3, right? So what I end up getting is a lot simplified version. 2 on the top, 3 over 3 is 1, times 4 over 1, times 3 over 3 is 1 over 5. And look at that. This is only 2 times 4 times 1 on the top, with 1 times 1 times 5 on the bottom. It's a child's play now. This is 8, this is 5. If you want to change it to a mixed number, this is an improper fraction. This is 1 whole because 8 divided with 5 is 1. The remainder is 3. And then you have 5 as the denominator. Done. 14 over 15 times 20 over 9 times 27 over 35 is actually equal to 1 3/5. This is exactly why you should first simplify and then multiply. I hope that makes sense. Let's talk about division involving fractions. In a division sentence, you can have a fraction as the dividend or the divisor or both. Let's go back to our pizza example. And let's say you have 2/3 of a pizza. So you cut the whole into 3 equal pieces. And you have with yourself all of this. So this is your share of the pizza. And let's say you have decided to cut your share into 3 equal parts. And maybe eat one of them now. So this is what you're going to eat now. Eat one of them a little later. And eat the rest sometime later in the day. And assuming all 3 pieces are of the same size, what fraction of the whole pie are you eating now or a little later or later in the day? So basically, what fraction of the whole circle is this region, the white region, or the orange region, or the region shaded in blue? To answer that question, obviously, because you start with 2/3, you don't start with the whole. So you have 2/3 to begin with, and you are cutting it into 3 equal pieces, which means you're dividing this with 3, right? So this is how you come across a division sentence involving a fraction dividend. Now consider another scenario when, let's say there's a party, or not even a party, let's say a small celebration you arranged at home for somebody in the family achieving something, and you ordered 2 pizzas, okay? So here are our 2 pizzas that you ordered, and you want to make sure that each person who's a part of that celebration receives 1/6 of a whole pizza. So this is the share for each person, and if you multiply this with the number of people who's a part of the celebration, you get the total number of pizzas, right? Share for each one times the total number of people is 2. So going by division and multiplication fact family, if you want to find out the number of people, so this one is going to be equal to 2 divided with 1/6. Am I right? If this confuses you, think about the sentence 3 times 4 is equal to 12. This is a multiplication sentence. So if you want to find this 4 out, this number, one of the 2 factors in multiplication, so you can get this by dividing 12, the other side, the product, with 3. That's exactly what I have done here. So if you want to find out this factor, you divide the product with this number, the other factor. So this is how you can have a division sentence with a fraction divisor. So let's now learn how to divide by a fraction. Have you ever noticed that dividing by 2 is the same as multiplying with 1/2? As a simple example, 10 divided by 2, which obviously is equal to 5, is the same as 10 times 1/2. So you know how to do this multiplication. You need to rewrite this 10 as a fraction. So 10 becomes 10 over 1. And then divide 10 with 2 and 2 with 2. Cross reduce. Simplify. So you have a 5 over 1 times 1 over 1, which is also equal to 5. So that works. Division with 2 is the same as multiplication with 1/2. Similarly, if you are dividing by 3, that's the same as multiplying with 1/3. 30 divided by 3 is 10. And 30 times 1/3 is the same as 30 over 1 times 1 over 3. Cross reduce, simplify 3 divided by 3, 30 divided by 3. You get a 10 over here. So this crosses off to give you a 10. And this one is a 1. So you have 10 times 1 over 1 times 1, which is 10. So we can say division with 3 is the same as multiplication with 1/3. Now 2 is nothing but 2 over 1. 3 is nothing but 3 over 1. So when you are dividing a number with 2 over 1, as we see here, the division changes to a multiplication, and this fraction, the second fraction, is flipped over. The numerator comes down and the denominator goes on the top. So we have 2 over 1 changed to 1 over 2, and the division changes to a multiplication. Look here. We had a division with 3 over 1. The division changed to a multiplication, and then the 3 comes on the bottom and the 1 goes on the top. You have 1 over 3. And you can actually extend this idea to divide any number with a fraction. Change the division to a multiplication and flip over the numerator and the denominator of the divisor. Therefore, 2/3 divided with 4/5 is going to be the same as 2/3, change the division to a multiplication, flip over the divisor. So 4 over 5 changes to 5 over 4. And then if you can simplify, go ahead and do it before you multiply. Over here, we can divide 2 with 2 and 4 with 2. So we end up with a 1 over 3 times 5 over 2, which is 1 times 5, which is a 5 on the top. 3 times 2 is a 6 on the bottom. So 2/3 divided with 4/5 is 5/6. In the same way, if you want to divide, let's say, 8/5, an improper fraction, with 16 over 15, you get 8 over 5. Division changes to a multiplication. Flip over the divisor. 15 goes on the top, 16 comes on the bottom. Cross reduce 8 with 8, 16 with 8, 5 with 5, 15 with 5. So you get 1 over 1 times 15 divided by 5 is 3 over 16 divided by 8 is 2. So this is 3 seconds, which can be changed over to a mixed number. This is an improper fraction, top-heavy fraction, so it can be changed over to the mixed number 1 and 1/2. Therefore, 8/5 divided by 16/15 is 1 and 1/2. Now here's a word of caution. Until before you learned about fractions, the general notion was probably like multiplication increases a number. So when you multiply a number, the number goes up. And when you divide, the number comes down. But when you enter the world of fractions, it's all jumbled up. Anything can happen. Take this one as an example. 10 is being multiplied. Now the general notion would be, when you're multiplying 10, the final answer is going to be more than 10. But then when you multiply with 1/2, which itself is a number that's less than 1, you end up getting 5, which is less than 10. Now let's say you are dividing 1/2 with something. The general notion is, since we are dividing 1/2, the final answer is going to be less than 1/2. But if you are dividing with a number that itself is less than 1, let's say you're dividing 1/2 with 1/4. Let's find out what the answer would be. You know what to do. 1/2, division changes to a multiplication. 4 goes on the top, 1 comes on the bottom. So you have 1 times 4 on the top. You could cross reduce, but this is pretty simple. And then 2 times 1 on the bottom, or you could do 4 over 2 and 2 over 2. Ultimately, what you have is 2 over 1, which is 2. So when you're dividing 1/2 with 1/4, the answer is 2. What's going on? You started with 1/2, you divided, you were expecting the answer to go down, it has increased to 2. And the reason is you are dividing it with a number that itself is less than 1. So this is pretty much as asking, okay, how many 1/4 will fit into 1/2? Now there are 2 1/4, so 2 quarters in 1/2. That's why you have the answer as 2. And the bottom line is, you should shed your old general notions about multiplications and divisions when you're working with fractions.